Okay, hello everyone. Um, yeah, this is actually my third time recording this because I accidentally end up um and the the recording in the middle and I didn't realize it. Okay, so yeah, let me start. So this worksheet is about potential and electric fields. So two charges Q1, we have two charges. Q1 is minus 4 microcoulomb and Q2 is 16 microcoulomb. They are placed with Q1 at the origin and Q2 at x equal to 2 centimeter. Okay. So A, let's verify that the electric field is 0 at x equal to 2. Okay. So here I label E1 as blue because it's generated by the negative charge, and label uh, E2 as red because it's generated by the positive charge. Okay. So the formula is the magnitude of the electric field equals to K times Q1, the magnitude of Q1 over R1 squared. Okay, and it's the same for E2. It's just we change Q1 to Q2 and R1 to R2. Okay, and then we insert the number. This 9 times 10 to the 9th is the constant K, here. Okay, and the Q1 we take the absolute value of it, so it becomes 4 times 10 to the negative 6 because it's a microcoulomb. Okay, and over 0.02 square because this distance is 2 centimeters, which is 0.02 meter square. Okay, and E1 and E2 it's the same procedure. We replace the Q1 with Q2, and Q2 is 16 times 10 to the negative 6. Okay, and R2 is 0.04 squared. And these two numbers is actually equal to each other. Okay, and therefore the electric field is 0 at x equals to minus 2. Okay, let me try to give some. 9 times 10 to the 9 times 4 to the 4 times 10 to the negative 6 and then over 0.02 squared. Okay, so this is E1 and E2 is 9 times 10 to the 9 times 16 times 10 to the negative 6 and divided by 0.4 squared. Okay. Yeah. So that you can see, I did something wrong here. Okay. So you can see that E1 and E2 they are equal. Okay. E1 equal they are equal. Okay. So let's move on to second question. Is the electric potential 0 at x equals to minus 2 centimeters? If not, what is it? So for potential, then we use this equation. V1 equals to K times Q1 over R1. And here we have no absolute value because we have to insert the sign of the charge here. And also V2 equals to K times Q2 over R2. Oh, but R here, the denominator R has to be positive, has to be an absolute positive value, which means that the distance has to be positive. Okay. So the blue, we insert Q1 R1, so this is K, and times Q1 with the minus sign in the front and over 0.02, and the same thing for the red part. Okay, so let's add these two numbers up. So V1, let's clear it. V1 is 10 to the 9 times minus 4 times 10 to the negative 6 over 0.02. So this is V1, and V2 is 9 times 10 to the times 16 times 10 to the negative 6 and over 0.04. Okay, and V1 plus V2 is not 0. This is actually 1.8 times 10 to the 6, or 18 times 10 to the 5th. Okay, so you can see that the electric potential is not 0 at x equals to minus 2. Okay, and then the third question, find all the places on the x-axis where the electric potential is 0. Okay, so let's assume that the position of this unknown position is x, and therefore R1, say this position is x. Okay, and R1 is from here to here, here to here. Okay, so it's the absolute value of x. R2 is from here to here, and it will be the absolute value of 2 minus x. Okay, so this is R1, this is R2, and we wrote them as k times q1 over R1 because this is V1 and this is V2. V1 plus V2 equals to 0, and we cancel out k, so it's q1 over R1 plus q2 over R2 equals 0, and we insert the value, so it's minus 4 over R1 plus 16 over R2 equals to 0. Okay, and then we insert the R1. Insert R1. We get R1 to be absolute value of x. R2 will be absolute value of 2 minus x. Okay, and we solve this equation. Okay, so it's something like this. So it's actually R2 equals to 4 times R1, and R2 is 2 minus x taking absolute value, and R1 is absolute value of x. Okay, so it's this equation, and then we square each side. We take a square of each side, so it's 2 minus x square equals to 16 times x square. Okay, and then it's equals to we expand this square, so it's equal to x squared minus 4x plus 4 equals to 16x squared, and then move all the terms from left to right, so it's 0.15x squared plus 4x minus 4. Okay, and we can actually factor this out into this 3x plus 2 times 5x minus 2. These two are equivalent. Okay, and we can find that x has two solutions, and the first one is minus 2 over 3, and the second one is 2 over 5, which means that on the axis, if this is x equal to 0, then this minus 2 over 3 means that we have a solution here, which is minus 2 over 3, and another solution here, which is x2 equals to 2 over 5. Okay, let's check the answer. Yeah, 2 over 5, and minus, it doesn't have a minus sign here, but it has a minus sign here. Okay, so it's minus 2 over 3, which means we have our first solution 2 over 5, it's around here, and our second solution minus 2 over 3 is around here. Okay, so yeah, this is all about this working sheet, and I'm looking forward to see you next week, and good luck on your exam. If you have any questions, feel free to ask me via email or text. Okay, so see you, bye.